Good morning, everybody. Our lesson today is indeterminate form and Lhopital role. In this video, I will show you how to applying Lhopital role in many cases, or what the cases as the student can apply Lhopital role. Before starting and talking about the Lhopital roles and Lhopital cases, how many cases we have to apply Lhopital role, all these questions, inshallah, we will show you how to apply Lhopital role in many cases. But now we concentrate just two main cases: infinity over infinity and 0 over 0. This is our lesson today. The outcomes for our lesson today: learn Lhopital role and identify the cases where it can be applied. The second goal is use Lhopital role to compute limits in various cases. Let's start here. Lhopital role. What is Lhopital role? Lhopital role, suppose that f and j are differentiable on the interval from a to b, except possibly at the point c belong to the interval from a to b, and that j prime of x isn't equal 0 on the same interval, except possibly at c. Suppose further that lim f of x over j of x as x approaches c has the indeterminate form 0 over 0 or infinity over infinity, and that lim f prime of f prime over j prime as x approaches c equal specific limit like L, or positive or negative infinity, then we can say lim f of x over j of x as x approaches c equal lim f prime of x over j prime of x as x approaches c. This is Lhopital role. Lhopital role, here in this role or this formula, we have two main cases: 0 over 0 or infinity over infinity. Be careful about this point. That is very important point to keep in your mind, where we can apply Lhopital role in two main cases: 0 over 0 or infinity over infinity. Let's show you in this example how to apply Lhopital. Here, evaluate lim 1 minus cosine x over sine x as x approaches 0. Let's start here how to solve this question. The first step here, I think you should substitute x by 0. This is the first step to check if we have the main one of the main cases of Lhopital role. 1 minus cosine 0 over sine 0. This is the first step. Just substitute x by 0. This is equal 1 minus cosine 0 equal 1. 1 minus 1 over sine 0 equals 0. This is equal 0 over 0. This case is Lhopital role. We can, after this, check. We can applying is in here. Applying Lhopital. Applying Lhopital's rule here in this case. Yes. What L'Hopital rule say? You should derivative the numerator and derivative the denominator. Here, what is the numerator? 1 minus cosine x. Derivative this. This is equal lim what? Lim 1 minus cosine x over sine x as x approaches 0. You should derivative of 1 0 cosine x derivative minus sine x. Okay, this is the derivative of the numerator. The derivative of sine cosine x is good. Here we can write here lim as x approaches 0. We can just here minus times minus positive sine x. Sorry, we can do something here. I think to leave more space to write. Okay, lim sine x over cosine x as x approaches 0. Now we can substitute x by 0. Okay, here sine 0 over cosine 0. This is equal what? 0 over 1. This is equal 0. We get it the specific limit as L'Hopital rule say. Okay, this is the first example. We can take another example to support you how to understand this. Okay, the another example here. Okay, the evaluate lim e to power x over x as x approaches infinity. The first step, as I said before, the first step, what we can substitute x by infinity. This is equal e to power infinity over infinity. This is equal infinity over infinity. This is the second case of L'Hopital rule. This is the second case. Be careful, 0 over 0 or infinity over infinity. Now we can apply L'Hopital here. Applying L'Hopital. L'Hopital rule. Okay, in this case, you should derivative the numerator and derivative the denominator. Okay, let's go. Lim. Okay, what the derivative e to power x? E to power x, the same. Okay, what derivative of x? 1. Okay, as x approaches infinity, now we can substitute e to power infinity over 1. This is equal infinity over 1. Okay, this is equal infinity. Okay, this is equal infinity. We can get it here. Yes, as L'Hopital rules, we can get it specific limit or infinity or negative infinity, positive or negative infinity. Here we can get it infinity, positive infinity. We can take another example here. Look to this question. Evaluate lim x squared over e to power x as x approaches infinity. The first step, step 1, we can substitute just here lim x squared over e to power x as x approaches infinity. Substitute here infinity squared over e to power infinity. This is equal infinity over infinity. Now this uh, is uh, Lhopital case. Okay, we can here put it infinity over infinity. The second step we can apply here, apply L'Hopital's role, and okay, you should here write lim x squared over e to power x as x approaches infinity. This is equal derivative of the numerator 2x over e to power x, because the derivative e to power x the same. Lim here as x approaches infinity. This is, I think, equal what? We can substitute now. This is 2 times infinity over e to power infinity. This is equal infinity over infinity. Is still L'Hopital case. L'Hopital, okay, case. The third step, I think here, third step here, apply L'Hopital's role again. Okay, we can here just substitute here lim 2x over e to power x as x approaches infinity, the derivative of the denominator 2 over 8 e to power x lim as x approaches infinity. We can substitute now 2 over e to power infinity. This is equal 2 over infinity. This is equal 0. This is equal 0. In this example, we apply L'Hopital rules twice, okay, to get it the specific limit. The specific limit is equal 0. Thank you for watching video. We will see inshallah in the next video many cases about the L'Hopital rules and sub cases from the main cases of L'Hopital rule. Thank you for watching this video. We'll see you inshallah in the next video.